Let's dive right into this explainer. Today, we're taking a journey deep inside the human body to look at one of the most complex, resilient, and historically devastating pathogens known to modern science. We're going to break down exactly how HIV operates on a microscopic level, what actually happens when it progresses to AIDS, and how some truly revolutionary scientific breakthroughs have completely changed the way we fight it.
To really grasp the scale of what we're dealing with, think about this number for a second: 40.9 million. That is the staggering amount of people living with HIV worldwide right now. If you picture a map of the Earth glowing with hotspots across different continents, you'll see that despite decades of incredible medical progress, this virus continues to affect millions of lives every single day. It's not just some relic of the past, it is a very present reality, and understanding it is absolutely crucial to combating it.
So to understand what HIV actually is, we have to zoom way, way down to the microscopic level. HIV stands for Human Immunodeficiency Virus. But the key thing here is that it's a retrovirus. And what does that mean? Well, unlike most organisms on Earth that store their genetic blueprint as DNA, HIV carries its genetic code as RNA. To multiply, a retrovirus has to do things completely backwards. It literally has to convert its RNA into DNA once it gets inside a host. It's a biological anomaly, and honestly, it's the secret to the virus's destructive power.
Now, when this virus enters the bloodstream, it doesn't just bump around attacking random cells. No, it has a highly specific target. It hunts down CD4 T cells. You can think of CD4 T cells as the commanders of your immune defense system. They're the soldiers guarding the fortress of your body, right? They identify threats and signal all the other cells to attack. HIV specifically docks onto these commanders, effectively targeting the exact system that was designed to destroy it. It's a terrifyingly brilliant evolutionary strategy.
What happens next is literally a microscopic biological heist. Once HIV attaches to the CD4 cell, the first step is injecting its viral RNA inside. Step 2 features this highly specialized enzyme called reverse transcriptase. It acts kind of like a decoder ring, taking that viral RNA and converting it into a strand of viral DNA. And finally, step 3 introduces another viral enzyme called integrase. And integrase acts like a malicious computer hacker, taking that newly minted viral DNA and permanently splicing it straight into the human cell's own genetic code. At that point, the human cell is completely hijacked.
But here is where the virus becomes particularly elusive. That conversion process we just talked about, from RNA to DNA using reverse transcriptase, it is incredibly sloppy. The enzyme makes mistakes constantly. And because of all these constant copying errors, HIV mutates at an astonishingly rapid pace. It turns into a literal mutation factory. And this is exactly why HIV can so quickly develop resistance to certain drugs, and why scientists have had such a massive, massive challenge trying to create a single effective vaccine.
Over time, this invisible battle takes a huge toll. A healthy immune system has thousands of CD4 cells acting as a robust shield against everyday external threats, things like bacteria, fungi, and other viruses. But as HIV multiplies and wipes out those commanders, that protective shield starts to shatter. Slowly, over years, the CD4 count plummets. When the immune defenses become so severely damaged that the body's protective shield essentially collapses, the infection progresses to AIDS, acquired immunodeficiency syndrome. This is the stage of advanced immune failure, where otherwise completely harmless infections, and even certain cancers, suddenly become life-threatening.
If we zoom back out from the cellular level to the global macro level, the devastation is just stark. This biological destruction disproportionately impacts sub-Saharan Africa. For instance, South Africa has the largest number of people living with HIV in the world, with roughly 8 million cases. Then consider nearby Eswatini. It has the highest adult HIV prevalence rate globally. At one point, roughly 1 in 4 adults there were living with HIV, and the epidemic actually dropped the country's overall life expectancy by 2 entire decades. The human toll is just staggering.
But here's the good news. Humanity has not been passive in this fight. Today, we've built up an incredible, highly advanced medical toolkit. We can stop the virus in its tracks through regular testing so people actually know their status. We use barrier methods like condoms and sterile needle programs. We also have PrEP, pre-exposure prophylaxis, which is a daily medication that's up to 99% effective at preventing HIV from sex when taken correctly. And for those already living with HIV, we have antiretroviral therapy, or ART, which stops the virus from replicating and allows the immune system to totally rebuild itself.
This modern medical arsenal brings us to an absolutely game-changing reality. It's called U equals U. Undetectable equals untransmittable. When a person living with HIV takes their antiretroviral therapy consistently, the amount of virus in their blood drops so incredibly low that standard tests can't even detect it.
The science here is amazing. When the virus is consistently suppressed to an undetectable level, there is zero risk of transmitting it to a sexual partner. Literally zero.
Infectious disease expert Dr. Allison Roger really hit the nail on the head when she said, if you're on suppressive RT, you are sexually non-infectious. The risk is zero. HIV is simply no longer the death sentence it was back in the 1980s and 90s. Thanks to modern medicine, people living with HIV can expect to live long, completely healthy lives, all while posing absolutely no risk of sexual transmission to their partners. It's a massive triumph for human science. So, we have the tools, we know how to stop it, yet we're actually at a really perilous moment. In 2025, global development assistance for the HIV response plummeted by 23%. That is the sharpest drop on record. Testing programs fell by 22% in high-burden areas, and funding for prevention stuff like PrEP and condoms dropped sharply too. At the exact moment when we have these revolutionary long-acting prevention tools hitting the market, the global funding that highly burdened low-income countries desperately rely on is being dismantled.
Which means, ultimately, the biology of the virus isn't even our biggest hurdle anymore. Our biggest hurdle is resources and resolve. With the scientific tools to stop HIV entirely right here in our hands, will the global community actually step up and fund the finish line? Or will we step back and let the virus hack its way right back into our most vulnerable populations? The science is ready. The next move is ours. Keep learning, stay curious, and thank you so much for joining me to understand the science behind HIV.